Literally everybody is talking about AI. YouTube tutorials everywhere, LinkedIn posts filled with AI buzzwords, and it seems like every computer science student is studying PyTorch and neural networks these days. But when you're studying, you are not well versed with what is happening in the industry, and you might be shocked to know that approximately 30 to 40% of new AI projects are being scraped off by these new companies that are popping up every single day. Not because AI doesn't work, but because they can't make these models work in production, cannot deploy them, cannot scale them. Like most of the tech companies, most of the engineering companies right now are using some form of AI, and they have data scientists, machine learning engineers, AI researchers. These have been positions that have been in contention since the last few years. These are the sorts of people who develop these underlying models. But what these companies don't have? People who can make these models work for millions, if not billions of users. In one of my previous videos in which I mentioned about the top skills that you want to learn, I mentioned AI infra, which is also called ML ops or machine learning operations, or whatever. The definition of this role is still popping up, and I got some comments on X and on the YouTube video saying, hey, can you tell us more about that? So this video is for you. Hey guys, I'm Anudeep. I work as a software engineer by the day, and on this YouTube channel, I make content on tech, AI, self-improvement, and entrepreneurship. So if any of those things sound interesting, please consider subscribing. Enough of the cheeky plug. Let's get started. Okay, so when I started looking into AI careers, I thought, literally assumed that you had to become some sort of a machine learning expert, right? Like learning all the math, building these models and stuff like that, because that is where the magic happens. But turns out that is just one of the paths that is available, and arguably the toughest one in terms of technical expertise required to master it. So there are actually three ways to work in AI. Path number one, AI researcher. These are the types of people who build these models from scratch. Like PhD level expertise. You're competing with MIT and Stanford grads, and I'm not taking names of these fancy universities. Like you can be from any university, but you have to have that amount of expertise and experience under your belt to be able to work in these fields. Path number two, machine learning engineer. Now this is where the crowd is headed. This is where the herd is, because these are the people who take these existing models and train them and fine-tune them. And to be able to do all of this, you need strong machine learning / deep learning basics, like super competitive. As I mentioned, everybody is doing this. And path number three is ML ops or AI ops, or whatever, AI infra engineering. And this one actually surprised me, because these are the types of people who take the models which are trained and fine-tuned by machine learning engineers and make them work in production, make them work for thousands, millions, billions of users, something which every company wants, because users will generate revenue, and that is downstream of everything. And you don't need hardcore mathematics for this, because you see, you are not building the algorithms from scratch. You are not building any algorithm for that matter. You are not an ML expert. But what you do need to understand, how the models work. There's a black box, what comes in, what goes out. You need to know all these things. But this actual black box, this actual model, this is somebody else's job. You are just concerned about the inputs and the outputs, like what is coming in and how are you making the outputs useful for the users. And you can go online and do the actual salary comparisons. It is very comparable to a machine learning engineer or an entry-level AI researcher, because there's so much demand for these sorts of people. As I mentioned previously, companies have already had data scientists and machine learning engineers and AI researchers for some time now, and they have their own version of AI that they want to use and they want their users to use. But currently, all of these things just work on their systems, and they need people to deploy it. They need people who can make these models work faster for the users, who can save costs, because if none of these things are happening, they'll just cut the project out. And that is the gap. Not that AI is not useful, not that AI didn't work, but that we didn't make it useful. Look at what machine learning engineers need versus an AI infra or an ML ops engineer needs. So an ML engineer needs machine learning theory, deep learning theory, mathematics, and requires a lot of effort upfront to be able to make it to the industry. Whereas an ML ops or an AI infra, or whatever you want to call it, because as I mentioned, it's still evolving, right? These are the people who are dealing with systems thinking, DevOps knowledge. Obviously, you have to have a basic understanding of machine learning, but that's that. AI infra is the same as DevOps, just that instead of applications, you'll be dealing with actual models. But the principles are identical: containerization, orchestration, monitoring, cloud management, all those skills, right? Like you've heard of those skills 1,000 times when you've heard of any DevOps engineer talking about their job. The only new thing, how models work, the basics of GPU programming, or the basics of GPU, something like model serving tools. But that's like 30% of new knowledge. Literally about 70% of the skills and knowledge you can import from your software engineering skills or degree and make it work in this new field. Because right now, every company, or should I say, every industry is adopting AI. Banking, healthcare, retail for that matter. I think over the next 10 years, 15 years, 20 years, every company will need a group of engineers who understand how these AI systems work and be able to deploy it for the people. Just like how people needed database engineers or cloud engineers when the internet bubble was picking up. Okay, so how do you actually learn this? You can actually click off this video, go to ChatGPT, go to Claude, go to Gemini and do your own research. Look at internet, look at other people's YouTube videos to have a look at their roadmaps. But this roadmap is what I have come up with because I have talked to a couple of people who have jumped in this field. I have personally not done it. I have not been through the grind. So, take everything with a pinch of salt. But if you still want to listen to it, let's go. So there's a clear pattern to people who have actually switched to this field and have actually been able to earn high salaries in this. And that is that they had a clear portfolio of projects that demonstrated their expertise and experience. So if you do anything, but if you're not documenting your projects and you're not showcasing your skills, it's not going to work out. And this is increasingly become the case in any field for that matter. Step number 1, learn Docker and Kubernetes. So what is Docker? I know a lot of you are, junior software engineers or maybe college students and you might not have heard of it. It is basically a system that makes your piece of code work on other people's computer. Like if you make your own piece of software, it has its own environment, it has its own dependencies. So it might work on your computer, but not on your friends. If you can just, box it up, package it up so that, when you transfer the files, all of that container is transferred to your friend's computer and that piece of software can just work fine in their system as well. That's what Docker allows us to do. It packages your entire app, code, dependencies, everything into a single container. So that container runs everywhere. Kubernetes, people call it K8s or whatever. I don't know the slang because I haven't worked in this particular sub niche of software engineering, but that's the next level. Docker lets you run one container. Kubernetes manages hundreds or thousands of containers at the same time. And I'm not going to go into the details of where you can learn what. Like if you want me to make a video on what sources you learn from, I can make a detailed video about that as well, but not in this one. I really believe that you can learn about all these things from ChatGPT these days. And if you're not learning to use Google or ChatGPT or Claude, then technology and software engineering as a field is not for you. Period. Let's keep going. So after that, you pick cloud. Pick any of AWS or Google Cloud or Azure. I think all of them have some sort of free plan, so you can just get started. And if you have interest and if your project takes off, or if you want to get more professional, you can pay for it later on, but it is absolutely free to get started. And so we cannot even make excuses saying that, hey, all these services are paid and stuff. So pick just one of these platforms and just learn the basics. How to spin up a server, how to store files, stuff like basic stuff like that. It might not look basic in the start, but this is basic and this is something that you should know going forward. So after learning all of this, I think by the end of first month, you should be able to have a simple app, like literally the simplest of app that you can think of, but that should be properly containerized with Docker, deployed with Kubernetes, and properly running on cloud. You don't need to be fancy. You're just proving that you understand how these things work in tandem, most importantly. Step number 2, learn AI basics. So I'm reiterating, you don't have to learn how to build these AI models, but how to use them. And by using, I don't mean learning how to use ChatGPT or learning how to use Claude, but how you can use the outputs of those to power your apps. And for that, you do not need any math. Although a fundamental knowledge of it will help, you just need to know what the model does, what it takes as input, what it gives as output for a particular query, and how you can train it in your own way. So all these things. After you're done with this basic theory, jump onto Hugging Face. And at this point, if you haven't heard of Hugging Face, it's like GitHub for AI models. They have 50,000-60,000 pre-trained models that you can use directly in your applications. Some of them are actually free to use. Images, classification, text generator, sentiment analysis, whatever, whatever you want to use. With the knowledge of all this, you also have to have a basic understanding of APIs and fast APIs so that you can take that information and present it in whatever form you want in your application or in your service, whatever you're building. Maybe you sort of build a Python function that takes text information, runs it through the model, gets the output, returns the prediction that you want to predict using that model through Hugging Face, if all of this chain is making sense to you. And then fast API wraps it on the API endpoint. And now anyone can send a request to your API, get the response back. Okay, at this point, the video has become a bit technical. I didn't want to make it this technical because the technicalities and stuff, you can figure it out on your own through other people's tutorials, through your own AI systems. I am not your teacher, right? Like, I am here to just guide you, just share what I have done. All of this was maybe one of the simple project workflows that I tried out while researching this video content. So, this is just an example, but you get an overall idea of what you need to do to be able to gain expertise and to be able to make yourself presentable for the job market. Step number 3, combine all of it into a proper project portfolio. Make 3 to 5 solid projects so that when you apply for jobs, you send them this portfolio. The HR and the recruiters, they are not just seeing your resume. They have your resume with your link. They click on the link. The API works. They get their predictions. You have all of it documented on maybe a Medium article or a Google Doc or whatever, or on your website, your web page, whatever it is. They can see all of your code properly documented on GitHub. All of this is proof that you can do the job, because in this job market, one of the best things that you can do to distinguish yourself from the crowd is to prove that you can do the job without actually doing the job. And for that, you have to have a lot of project experience. You have to have a lot of free work under your belt, like doing professional work but not getting paid for it by anybody, because you're doing it for yourself to be able to add those projects on your portfolio. And that's how you build proof of work. So yeah, you do not need a degree for this. You do need a lot of project experience for doing all of these things, and AI will not be able to take this job, because although AI is generating code, although AI is generating essays, we need people. These big companies, small companies, medium-sized companies, all sorts of companies need people to be able to deploy these marvelous, amazing models and make it available for the common people. Like, not everybody is a coder, not everybody is a software engineer. I think one of the pitfalls of being in a university or a class is that you feel that, hey, like this knowledge is so common and everybody knows Python and they know machine learning and stuff. But no, you are surrounded by 60, 70, 100, 200 people who are studying the same courses as you, doing the same projects as you, are in the same vibe as you, are maybe watching the same creators on YouTube, are living the same life as you. And so it can seem like this is so normal, but it is not. Literally, you can put your heart and soul for 4 months, 6 months onto something, build something every single day, ship something every single day, post about that every single day, and I am guaranteed you will be in one of the top 0.0001% of human population in that particular field. With that being said, I hope you found this helpful. Let me know down in the comments below what you found helpful and what you did not, and what you would want to know more from me. I read all of your comments. I don't get time to reply to them, but I do get to them eventually, so feel free to leave them. And if you are still present watching this video, thank you so much. It always means a lot, and I will see you in the next one. Peace.